All right, today we're going to learn a little bit about special right triangles. You have guided notes to help you through with this, so you should fill in your notes as we walk through the notes here. I'm going to tell you right up front that this is a special kind of thing to remember, that you can actually do all of this using the Pythagorean theorem, but if you'll remember some of these special properties, it'll help you out when it gets to the ACT. On the ACT, you have 60 questions that need to be completed in 60 minutes. So if you can remember some of these properties, it will help you out. This is definitely something that shows up on the ACT all the time. So guys, I guess what you need to know is that what you're doing today can be done with the Pythagorean theorem, but that's a much longer process than what I'm going to show you here. All right, so first of all, there's two types of special right triangles. You need to fill in these blanks. There are 45, 45, 90 triangles, and there are 30, 60, 90 triangles. So what we mean here is these are the measures of their angles. So we know it's a right triangle, so we know it has a right angle. And what we're saying is that the other two angles here are 45 and 45, okay? Or for this case, there's a right angle. One of the angles is 30 degrees, and one of the other angles is 60 degrees. Okay, so these are two special cases, 45, 45, 90, or 30, 60, 90. And we can kind of use the Pythagorean theorem, but we can also learn the patterns and use these to be a little quicker with problems. All right, so in a 45, 45, 90 triangle, let's just go ahead and use the Pythagorean theorem and see what the pattern comes out to be. This over here is my hypotenuse, so I know this is 5 squared plus 5 squared equals x squared. Okay, 5 squared is 25, so 25 plus 25 equals x squared. 25 and 25 is 50. All right, and then I know I need to square root both sides. So this is going to be x equals the square root of 50. And then if I think about my simplifying of radicals, 25 goes into 50. So this is like the square root of 25 times 2. So this is 5 root 2. Okay, so the hypotenuse in a 45, 45, 90 triangle, I have the two sides that are the same, but the hypotenuse is that side length, 5, times the square root of 2. Okay, so that's the property we're going to see here on the next slide. Okay, the two sides that are the same, it's an isosceles triangle, the two sides that are the same are x. The hypotenuse is x times the square root of 2. So whatever number these sides are, the other side is x times the square root of 2. Okay, the nice thing is on the EOC at the end of the year, this little table right here is given to you on a reference sheet. So as long as you can understand what this means, you can apply this property. We'll do a couple examples here at the end. Okay, so the two sides that are the same are x. The side across from the right angle, the hypotenuse, is x times the square root of 2. All right, let's look at the other situation. The other situation is a 30, 60, 90 triangle. Okay, what I see here is I have a short side, I have a long side, and I have a hypotenuse. Okay, let's find out what the length of this long side is, all right, in comparison here. So there's my hypotenuse. So I know I have, and we'll go ahead and call this x. I have 4 squared plus x squared equals 8 squared. 4 squared is 16 plus x squared equals 64, 8 squared. Okay, I got to subtract here, so x squared equals 64 minus 16, which is 48. Okay, and then I have to square root both sides. So x is the square root of 48. Okay, and again, I'm going to expect you to simplify these radicals. So x equals, okay, 16 goes into 48, so this is 16 times 3. So x equals 4 times the square root of 3. All right, and if I go back and look at this in comparison to what I have here, it's the shorter side times the square root of 3. Okay, I also should notice here is 4 for the short side. The hypotenuse is 2 times that. Okay, so here's our pattern for 30, 60, 90 triangles. Okay, the short side, the side across from the 30-degree angle, is x. The hypotenuse is always 2 times that. And the side across from the 60-degree angle, the longer side, is always x times the square root of 3. Okay, so let's try to use these properties as we're working through some problems. Okay. Oh, and my shortcut for remembering this, if there are two sides in the triangle that are the same, so a 45, 45, 90 triangle, we're going to have a square root of 2 as part of our pattern. If the three sides are all different, we're going to have a square root of 3 in part of our answer. So here are a couple more pictures that kind of show these relationships. The length of the two sides that are the same, and the length of the hypotenuse is L times the square root of 2. Here we have the short side is S, the hypotenuse is 2S, and the longer side is S times the square root of 3. Okay, so that's just kind of how I remember it, if that is helpful to you. All right, let's try a couple of examples. These are 45, 45, 90 examples. Okay? And so we're going to remember the 45, 45, and 90, that this is x, okay? And the side across from the 90-degree angle, the hypotenuse, is x times the square root of 2. Okay, so let's apply that to this problem. If this is 7, okay, then I know this side and this side are congruent, so this side is also 7. And in this case, x is merely 7 times the square root of 2. I don't have to do any math to figure that out. I just follow the pattern. Okay, you absolutely could plug this in to the Pythagorean theorem and find out what that side is, okay, but you don't have to. All right, it works the other way as well here. I'm solving for u here. I'm given that the hypotenuse is 8 times the square root of 2, so I know that these two sides out here are both 8. So u equals 8, just following the pattern. Very basic. Okay, let's try some 30, 60, 90. All right, so 30, 60, 90. Right here I'm given the shortest side. This is the short side, this is the long side, and this is the hypotenuse. Okay, probably the easiest relationship is to go from the short side to the hypotenuse. Okay, u is going to be twice the short side. Okay, we remember again, across from the 30 is x, across from the 60 is x times the square root of 3, and across from the 90 is 2x. Okay, so 2 times 8 is 16. And then v is merely the short side times the square root of 3. So 8 times the square root of 3. Okay, so you're noticing that I don't really have to do any math here at all. These are pretty basic problems, especially when they're set up this way. All right, here I'm given the hypotenuse. The hypotenuse here is 10. So now I'm going to work backwards. Okay, if the hypotenuse here is 10, then I know the short side is half of that. So the short side here would be y, which is 5. And then the longer side is that short side times the square root of 3. So again, 5 times the square root of 3. Okay? You may need to watch through these examples a couple times just to make sure that you're understanding the pattern. But in my opinion, this is way easier than the Pythagorean theorem. Okay? And honestly, in a problem like this where you're not sure of two of the sides, you would need to know these patterns to be able to get to these answers. Okay? Let's look at a couple trickier examples, though. In both of those, we were given kind of what we wanted to be able to figure these out. All right, in this problem, we're given a little bit more difficult work. Okay, first of all, this is the 30, 60, 90 triangle, and so I'm going to write down my proportions again, 30, 60, and 90.